balloon, the Gemsphere, has completed its run at 56,700 feet, and that data is now being processed. Much of the activity over the last week has been associated with changing out Discovery's #1 auxiliary power unit, which was removed last Saturday and sent back to the vendor for analysis. A new one was on hand and ready for installation, and we have video of that unit being prepared for transportation to the launch pad.
Discovery Houston, Simo air to ground voice check, steady read.
The auxiliary power unit, which presented the problem, was found to have a chip in one of the valves that's involved with regulating the flow of hydrazine. Therefore, what we found was a one-time hardware problem and not an overall design or engineering concern. This is the replacement auxiliary power unit being prepared for transportation. In the back, there is the one that was taken out and was shipped back to the vendor for analysis.
Altimeter setting of 30.
That is the aft area of Discovery where the replacement auxiliary power unit will be installed, and adjacent is the external tank and the solid rocket boosters.
What we're working, manual right now is a single string for tack ants.
The replacement
We're planning on going
unit was transported to the pad on Saturday and was connected on Sunday. Most of that work was completed in time to give most of the team the rest of the Easter Sunday period off. After the installation, the replacement auxiliary power unit was hot-fired, was run for a little over 5 minutes to verify that there would not be a repeat of the problem that we had before, and to give it the same amount of runtime as the other auxiliary power units which are on board Discovery. And that test went fine.
Okay, Steve, we copy.
This now is going into the aft area for the installation. In parallel with this activity, the payload bay doors of Discovery were closed and the batteries for the Hubble Space Telescope were back in the battery lab being charged. This procedure had not been done vertically before. It had been done in the hangars, so that procedure was modified with some contingency time built in to allow for any problems should they be encountered, this being a new approach. However, the change out and the retest went very well. Most of that contingency time was not used, and with the Hubble battery charging getting started a little bit earlier, then all things came together to make it possible to move up our launch date from the 25th to the 24th.
And that's the Northrop 2-3.
We're now at T-minus 31 minutes 50, T-minus 30 minutes 55 seconds and counting, leading toward an 8:31 a.m. liftoff this morning. This is Shuttle Launch Control.
TWS OTC. TWS, go ahead. Can you verify anything on your CRTs? G and 2 press. Yeah, they're verified. Copy. OTC. C1C, go ahead. Okay, you want to pick up 774, please? 774 through 778 are complete. Copy that. OTC, Seattle. Go ahead. Yes, sir, step 787 is complete. Copy. Clock. OTC, CCD. Go ahead. 768 complete. Copy. LVCC, OTC. ISL OTC. So go ahead. Are you ready for the next pre-flight bites? Yes, I am. EPD. EPD copy. OTC, EPD. Go ahead. I can give you step 790. Okay. CLS OTC. CLS 212. Yeah, you want to pick up 791 by the clock, please. Copy, 791 by the clock. OTC, CL212. Go ahead. I can give you step 807. Copy that. CDR OTC, air to ground 1. CDR, go ahead. Can you report your cabin press at this time, please? The gauge looks like about 14.8. Copy that. ACL. Okay, on 809, I have 14.82. Okay, CDR on the CRT3. ESS system page 1. Report your cabin press, please. And OTC CDR cabin press is 14.7 on the CRT. Copy that. And CDR, at this time, you can close your cabin vent valves. Didn't work. OTC, CDR, both the vent ISO and vent are closed. Copy that, ACL. And I can give you 814. Copy. PVD OTC. This PVD, go ahead. We're going to be performing steps 821 through 23. Negative, will be all not performed. AFM OTC. AFM, go ahead. You can do your start tracker door open indication status countdown clock will hold at T-minus 20 minutes in approximately 4 minutes. OTC AFM. Go ahead. I can give you step 831. Copy. All operator systems on channel 212. Verify your program software and report only if any discrepancies. CVFS OTC.
CVFS.
And RAS number for me on 827.
That's 031.41.
Thank you. ARPS OTC. ARPS OTC channel 212. ARPS? Yeah, you want to pick up step 838 and change the MTU test set to delay 0? That's complete. Thank you. GPS OTC.
Yes,
Can you verify 2 consecutive OC task concurrencies available?
that's verified.
Thank you.
This is shuttle launch control at T-minus 20 minutes, 30 seconds, and counting. We are preparing now to enter the T-minus 20-minute built-in hold. This hold will last for 10 minutes. During this period, the NASA test director will ask members of the launch team to verify that the proper software has been loaded aboard for the remainder of the countdown, and we'll get verification that the pre-flight inertial measurement unit alignment has been completed. Going into the hold now in 3, 2, 1, T-minus 20 minutes and holding for 10 minutes. The landing and recovery director has reported that the shuttle landing facility is ready and configured for launch and has verified that the booster recovery ships are on station and ready to support. The NASA test director is about to brief the launch team on recycle options during the remainder of the countdown. From now until T-minus 31 seconds, any of the console operators can ask that the countdown be held if a problem is detected. After T-minus 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle back to the T-minus 20-minute mark. The launch director has just been given an update on the weather. We continue to see mostly scattered clouds offshore, gradually moving onshore, and they are not expected to be a constraint. As they move onshore and into the area, they are being evaluated by Dan Brandenstein in the shuttle training aircraft as he makes approaches to the shuttle landing facility. Overseas, Banjul weather is acceptable, reporting clouds 12,000 scattered, 20,000 thin broken, visibility 6, and northeasterly winds 10 to 15.
KBFX active on 212. HTD.
Here at KSC, our winds running mostly from the east at 10 to 12, and the status board at the Cape Canaveral forecast facility reflecting shuttle weather constraints is all green at this time. At T-minus 20 minutes and holding, this is shuttle launch control.
SRO, NTD 212. SRO, NTD 212. NTD, this is GOS. I see him coming in weak. We're working the problem. Copy.
NTD CGLS on 212.
Go ahead, Joe.
Yes, sir. The countdown clock will start at 12:01 GMT.
Copy. OTC EPD. Go ahead. Did I get a CMQC on 151? CMQC OTC. The CMQC, go ahead. Yeah, EPD OTC. Go ahead. What are you doing? Either for the fuel cell load sharing address. Okay, yeah, 151 QC. Stop looking at it. Copy.
OTC CFCP.
Go ahead.
Yeah, can we get a CMQC on 153?
Same thing?
That's fine for our purge.
Okay. CMQC. Copy 153.
OTC, Seattle.
Go ahead.
Yes, sir. We also need a CMQC on 145 for our recorder activation later on.
CMQC.
Copy 145.
SRO NTD 212.
NTD RSO, read you loud and clear on 212. 212.
RSO NTD 212.
NTD
RSO NTD, do you copy on 212? OTC TP. Go ahead. Pass through to COOS on 161. COOS OTC.
Yeah, go ahead.
Yeah, can you go 161 with TPE, please?
Yeah, going to 161.
NTD safety 212. Go ahead, sir. Yes, sir. I can give you step 966, closeout crew at AB11. Have you got any words on step 798? STM NTD. STM NTD 212. STM, go ahead. You have a verification of 798. We've got the CCF clear. We're still waiting on the LDA. Copy. This is NTD on 212 and 232 conducting the T-minus 20-minute briefing. The launch window opens at 12:31 GMT and closes at 18:43 GMT. A second launch attempt is possible if a recycle occurs. There are 3 COLAs for today. COLA 1 opens at 12:58:30 GMT and closes at 12:59:30 GMT. COLA 2 starts at 14:32 GMT and ends at 14:37:30 GMT. COLA number 3 opens at 16:12 GMT and closes at 16:13 GMT. If a hold is requested and issued between T-minus 9 minutes and T-minus 31 seconds. The countdown clock will be restarted upon successful resolution of the problem without a go survey made of all elements. PLT at T-minus 5 minutes, perform APU start upon command of OTC only.
CLT copies.
CDR, the pad egress system is nominal and the evacuation helipad is 8.
Okay, we copy 8. Thank you.
Fine room launch team, disable telephone ringers at this time. Ingress and egress of the fine room will not be allowed after resuming the count at T-minus 20 minutes until after launch or flight crew egress if a recycle occurs. If an extended hold is required at T-minus 9 minutes, limited fine room access will be allowed. All personnel bear in mind that critical post-launch operations will be in progress after a successful launch, so keep fine room activities and noise to a minimum. Are there any questions? That concludes the briefing. Flight entity. Houston flight entity 212. Houston flight NTD air to ground 1.
Okay, NTD flight 212.
Okay, step 897A, you can proceed with transmission of your variable ascent parameters.
Hey, welcome.
And flight, can you verify that you're ready?
Correct, sir.
Houston flight entity.
This flight go.
Step 898, can you verify ready to resume the count at 20 minutes?
Okay, stand by 1 second, NTD. NTD flight is go.
Understand. The countdown clock will start at T-minus 20 minutes in 2 minutes.
OTC CTNC, go. I can report step 897. IMU pre-flight alignment is complete. Ready for transition to OPS 1. OPS transition must occur within 10 minutes. Your GMT time there is 11:58. 11:58, copy. And I can also report completion on steps 899 and 900. Copy that.
NTD copy.
NTD STM 212.
Go ahead, STM.
Okay, steps 794, 798, and 819 complete.
798 and 819, is that affirmed?
That's correct, and also 794.
Copy.
All personnel on channel 212 this OTC after transition to OPS 101, discontinue all LDB PMU reads for remainder of count.
Safety console entity. Safety console 798 is complete. Copy.
This is shuttle launch control at T-minus 20 minutes and holding. We are just about 1 minute away from picking up the countdown at the T-minus 20 minute mark.
Yeah, CMKC.
As we come out of the hold, Discovery's onboard computers will transition into the terminal countdown configuration, and we will dump the computer memory of one of the 4 primary computers so that we can look at the data and make sure that the OPS 101 program, which is the primary program, has been stored properly and that there are no unexpected results.
Copy that.
Taking up the count now in about 20 seconds.
I copy that. Station 966 also.
Again, we're still aiming toward an 8:31 a.m. liftoff. We have no constraints with the shuttle or weatherwise. Picking up now in 5, 4, 3, 2, 1. T-minus 20 minutes and counting.
SCP OTC.
Purge of Discovery's 3 fuel cells is now underway. The data processing system engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration.
Loud clear, I copy.
We do have 3 COLAs today during the period, which extends from 8:31 to 2:43. There would be a collision avoidance quotient that would begin at 8:58:30 this morning and run for 1 minute. There would be another one at 10:32 this morning, which would last for 5.5 minutes, and another one at 12:12 this afternoon, which would last for 1 minute. That last one, however, would be academic in light of the fact that the crew time in the cockpit of Discovery would expire at 11 a.m.
here to ground 1.
All activity continues on schedule as we proceed toward the next hold at T-minus 9 minutes. The primary ascent software is now in the Ops 101 mode, which is the primary launch program, and Commander Shriver will now configure the backup flight system computer to match that configuration. T-minus 18 minutes, 20 seconds and counting.
NPD STM 212. Go ahead, STM. Step 916. Will that be performed or not performed, sir? That's not performed. Copy.
OTC, CDR, PFS is an Ops 1, no unexpected messages.
Copy that, thank you. And PLT, OTC.
Go ahead, Sam.
Okay, configure pass and VFS horizontal SIP displays per your checklist, please.
Commander Shriver has reported that the backup flight system is now in the proper mode, and we just saw astronaut Dan Brandenstein flying the shuttle training aircraft, doing the weather reconnaissance and assessing the conditions at the shuttle landing facility in the event of a return to launch site abort. He's reporting that data to support astronaut Ken Reichler and astronaut Jim Weatherby here in the firing room. T-minus 17 minutes and counting.
Go ahead.
The BFS pre-flight uplink load is complete.
Copy. CVFS.
CVFS copies.
Dumping of the Ops 101 program stored in the memory of one of the 4 redundant general purpose computers is now underway. That will take about 7 minutes to complete. Engineers will be examining that data for anything that would miscompare.
Go ahead, PLT.
Okay, horizontal fit. Yeah, Stan, horizontal fit config is complete, and we've verified the OHM's interconnect config is also verified.
Okay, copy that.
Pilot Charlie Bolden has been in the process of configuring the cockpit switches for launch, and he's reporting that most of that configuration is complete. The airframe engineer is checking all of the critical movable aerosurface driver currents and is positioning all the hydraulic systems for activation.
NTDSRO, go ahead, sir. 969, KSC area is clear for launch. Roger, copy.
OTC PLT, MPS helium reconfig is complete.
Copy that. NPS, OTC.
MPS go.
Okay, you verify 945, 946.
Verified.
And 47?
Yeah, yes, sir.
Copy that. Double OS. Go ahead. Okay, configuring OHM's RCS cross feed for flight. At this time, yes. Copy.
Pilot Charlie Bolden has reported that the helium system reconfiguration has been completed. This opens helium isolation valves necessary for the in-flight purges of the engines.
Checking, sir.
Water levels in the water spray boilers are now being checked, and they are being verified to be sufficient for the mission. The NASA test director has asked Houston Flight to send their pre-flight uplink command to the orbiter's backup flight system. These loads are sent from the Mila tracking station here at KSC and put the 5th general purpose computer in the proper configuration for launch.
NTDSRO 212. Go ahead. Yes, sir. Page 813, step 0965, normal track. Copy.
Configuration of the cross-feed valves between the orbital maneuvering system and the reaction control system propellant tanks is being performed. The orbiter test conductor has asked pilot Charlie Bolden to report the quantities in the reaction control system propellant tanks. Meanwhile, the booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid rocket boosters prior to their ignition. We're at the point now where all non-essential personnel are being cleared from the launch danger area. The white room has been closed out for flight, and the closeout crew has departed back to the roadblock.
MTD, STM 212. Step 986, sir. Copy. And FCP, OTC, here to ground 1.
FCP?
Yeah, your fuel cell purge complete?
Will be shortly.
Copy. Countdown clock will hold at T-minus 9 minutes and 4 minutes.
OTC, CFCP.
Go ahead.
Our fuel cell purge is complete and we're ready for fuel cell load adjustment.
Okay, EPD and ECL and FCP, adjust your fuel cell loads for the Ds. EPD copy.
FCP copies.
ECL copies. OTC, CVFS.
Go ahead.
T-minus 20 minutes, CTC dump is complete.
Copy that. CMQC, it's 979. Copy 979.
T-minus 12 minutes and counting, we've received word from White Sands that the weather reconnaissance aircraft there has advised that with the wind that they're seeing, there is still ample margin out there to cover any contingency in the event that we should have an abort once around. He has reported his observations to the chairman of the mission management team, Brewster Shaw, and Brewster has determined that weather at White Sands is go for launch. We've also received a verification that all of the contingency support is ready and that the aircraft and emergency teams are on station to support the launch today.
Copy that.
The T-minus 20-minute dump of the orbiter general purpose computer memory has been completed. We have no unexpected errors in that report. Now T-minus 11 minutes and counting.
Load adjust is complete. Copy that. ECL. ECL OTC.
Go ahead.
Yeah, can you agree with fuel cell? EPD?
That's affirmative.
Copy. All personnel on channel 212, this OTC, discontinue all non-mandatory LDB traffic for remainder of count.
T-minus 10 minutes and counting, about 1 minute now from the last planned built-in hold in the STS-31 launch countdown this morning. The flow rate of the conditioned air fed into the orbiter's payload bay is being reduced and will be verified at about 180 pounds per minute, which is the figure desired for launch. Standing by now to go into the hold at T-minus 9, 3, 2, 1, T-minus 9 minutes and holding for 10 minutes. We will emerge from this hold at 8:22 Eastern Time. When the countdown resumes, the ground launch sequencer will be in control. The master computer program will issue the commands to perform all of the final critical tasks required to put the vehicle in its launch configuration. During that time, it will be monitoring as many as 1,000 different parameters in that last 9 minutes to make sure that they do not fall out of any predetermined limits that the launch team calls red line. All personnel in firing room 1 have now switched over to the same communications channel, and they will be staying on that through launch.
This is NTD on 212, taking a status check for launch. Say go, no go for launch. OTC?
Go.
TVC?
Go.
PTC? Go. LPS?
Go.
Flight? Houston flight, NTD. Nala? Nala, NTD. STM?
STM, let's go.
Safety
Would it be
console.
legal to
Safety
call
console.
my lady?
Safety console.
Now about 2 minutes into the T-minus 9-minute built-in hold. We'll go now to Mission Control in Houston for a readiness statement, and also to the Space Telescope Operations Control Center at Goddard. They will report their readiness. Going now to Mission Control in Houston.
This is Mission Control Houston. Flight controllers in the Figure 1 room are ready for launch. The flight director for Ascent, Von Dittemore, just polled the room, and all positions reported they will be go for coming out of the T-minus 9-minute hold. One slight change to this morning's plans for launch. Ben Guerrier will be designated as the prime transatlantic landing site with Banjul as backup due to a problem with the primary TACAN system at Banjul. The secondary TACAN system is operational, but since weather is good at both sites, we will be choosing Ben Guerrier as the prime transatlantic landing site this morning. No other systems problems are reported, and all positions in Mission Control are standing by for launch. This is Mission Control Houston. We'll hand over now to Hubble Space Telescope Operations at Goddard.
Wheels, channel 118 X-ray.
This is Hubble Telescope Control Greenbelt. The Director of Orbital Verification, Mike Harrington, has confirmed that all control team positions here at the Space Telescope Operations Control Center in Maryland and the support team at the Huntsville Operations Support Center in Alabama are ready to support today's launch of the Hubble Space Telescope. Approximately 3 hours ago, the crew configured switches aboard the orbiter to provide essential power to 3 telescope systems. The telescope's receivers were powered to ensure that they are warm and on frequency to receive initial commands from the control center following launch. Heaters for the rate sensing units were powered to maintain the gyros at a stable temperature, and power was applied to the fixed head star tracker shutters to ensure that they remain closed during launch. Otherwise, the telescope is essentially powered down in Discovery's cargo bay and ready for launch. Beginning approximately 4.5 hours after launch, controllers here will begin sending commands to systematically activate the telescope systems in preparation for tomorrow's scheduled deployment. Again, all is ready here in the control center at Goddard Space Flight Center, Greenbelt, Maryland, and at the support center at the Marshall Space Flight Center in Huntsville, Alabama, for today's launch of the Hubble Space Telescope. At T-minus 9 minutes and holding, this is Hubble Telescope Control Greenbelt, returning now to the Launch Control Center.
This is Shuttle Launch Control in Firing Room 1 of the Launch Control Center at KSC, where we have approximately 5 minutes remaining in the T-minus 9-minute built-in hold. Several milestones remain between now and launch. As we come out of the hold, the ground launch sequencer will take over control and issue commands for the final critical task and monitor the hundreds of vehicle measurements that are coming in during the final 9 minutes. At T-minus 7 minutes 30 seconds, the orbiter access arm retraction will be performed.
No constrained explained condition.
And at T-minus 5 minutes, pilot Charlie Bolden will start up the orbiter's auxiliary power units.
SMSD as in dog.
A gimbal check of the orbiter's aerosurfaces will occur at T-minus 3 minutes 55 seconds. And switch over to internal power occurs at T-minus 3 minutes 30 seconds. And then the orbiter's main engines will be gimbaled or moved at the T-minus 3 minute 25 second mark. LOX tank pressurization and retraction of the GOX vent hood will start at T-minus 2 minutes 55 seconds, and the liquid hydrogen tank will be pressurized for flight at T-minus 1 minute 57 seconds.
Launch director, with that, the team is ready to proceed. That's step 1016.
Okay, I'll conduct my poll at this time. Payload operations director.
Launch director, payloads are go.
Copy, engineering director.
Engineering is go.
Copy, safety and quality director.
Safety and quality is go, Bob.
Copy, Cape weather.
We have no weather launch constraints violated. Launch wind forecast from 09 to 0 degrees at 10 knots.
I copy, operations manager.
Bob, we have no constraints and you are go to proceed with the launch.
Copy, thank you, sir. Discovery launch director. Air to ground.
Discovery, go ahead.
Okay, well, at the risk of being repetitious, we're here again, and everything looks good. Shuttle, ground systems, and the Hubble, and we believe the universe is still go. So we hope we can get you up there to take a look at it today. Have a good one.
Okay, we sure do. Thank you very much. Looks like it's been a good countdown here.
Yes, sir, and NTD, you have go to proceed.
I understand, thank you. Flight, ISL, RPS, NTD.
Just flight.
ISL.
This is ISL.
JRPS. JRPS. Okay, step 1012, you can activate recorders. Copy.
TVD OTC.
This DVD, go ahead.
Yeah, we have a payload bay purge rate since the launch of this time.
That's confirmed. We just completed it. It's stable at 178.
Copy that.
With it outperformed on step 1009.
Copy that.
NTD flight recorders have been activated.
Copy. Countdown clock will start in 2 minutes. ISL, did you copy that the recorders are active?
NTD, CNSE.
Go ahead, CNSE.
Yeah, overheard changing tail sights to 118 X-ray.
That's firm. And we're now Ben Greer.
And they changed those sun wheels yet?
That's firm.
Copy.
1 minute and 30 seconds from picking up the countdown at T-minus 9, where we will press on toward the handoff of the ground launch sequencer to Discovery. The onboard computers will then start their own automatic sequence, and the final commands will come at T-minus 10 seconds to provide the concurrence for a go for main engine start. The engine start will occur at T-minus 6.6 seconds and solid rocket booster ignition at T0. The orbiter's computers will issue the commands to start, and the ground launch sequencer will concur. 45 seconds now to picking up the countdown. "30 seconds away from picking up at T-minus 9. Nothing is reported amiss, and we are go for picking up the count in 10 seconds.
Countdown clock will resume on my mark. 5, 4, 3, 2, 1, mark. TLS auto sequence has been initiated.
Now into the final phase of this morning's launch countdown with the initiation of the ground launch sequencer. Standing by now for a request from the orbiter test conductor to Houston Flight to send stored program commands, which are the final update on the antenna alignment.
PLT was that, OTC was that for the PLT?
That's affirmative. Configure fuel cell essential bus source switches, please.
That's in work, Stan.
Thank you.
OTC PLT, essential bus connection is complete.
Copy that, thank you.
Next significant event coming very shortly here with the orbiter crew access arm being retracted away from the vehicle into the launch configuration. This arm can be re-extended in less than half a minute if that's necessary. T-minus 7 minutes, 30 seconds and counting.
TLS's go for orbiter access arm retract.
In about 45 seconds, the orbiter test conductor will give pilot Charlie Bolden a go to perform the auxiliary power unit pre-start. Bolden will configure switches in the cockpit to put the APUs in the ready-to-start configuration. The APUs will be started at T-minus 5 minutes. Go for APU pre-start will come in about 10 seconds.
You want to start your APU hydraulic strip chart recorders, please. Recorder started. And PLT OTC.
Go ahead.
You can perform your APU pre-start, please.
That's in work.
The APUs provide hydraulic power to the orbiter. Standing by for confirmation that the APU pre-start is complete.
Pre-start's complete. 3 great talkbacks.
Thank you, Charlie.
Pilot Bolden reporting back that the pre-start operations are complete. T-minus 5 minutes, 30 seconds. Mission Control has transmitted the signal to start the flight recorders. The 2 recorders will collect measurements of the shuttle system's performance during the flight for playback later after the vehicle is in orbit. Coming up on T-minus 5 minutes and counting.
TLS's go for orbiter APU start.
And we have a go for APU start.
APUs, please.
That's in work, Stanley.
And CDR OTC.
Go ahead.
You can reconfigure heaters, please.
Commander Schreiber asked to reconfigure the orbiter heaters. He'll report when that's complete.
Heaters are reconfigured.
Thank you.
The ground launch sequencer has terminated liquid oxygen replenish to the external tank and is now initiating the LOX drain back.
And OTC, PLT, APU start is complete, and so far so good.
There are the good words. 3 APUs in good health. About to start a profile test. Profile test of the orbiter's aero surfaces. The orbiter flight control surfaces are being moved through a pre-programmed pattern, and we'll have a gimbling of the main engine, which will follow. Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. At this point, Discovery is being powered by the onboard fuel cells. T-minus 3 minutes and counting.
Ulysses go for ET-LO2 pressurization.
Go for pressurizing the external tank. All systems are go for launch.
OTC 212. Go ahead, OTC. Okay, clear caution and warning memory and verify no unexpected errors. Okay, we have no caution and warning annunciation, Stan. That's complete. Thank you, Charlie.
Standing by now. Here is the retraction of the gaseous oxygen vent hood. The gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212. Close and lock your visors and initiate your O2 flow, and you all have a good trip. Roger that. 10 word.
Ulysses go for ET-LH2 pressurization.
Bringing the LH2 pressurization up to flight levels. 90 seconds away from launch now.
1 minute, 30 seconds.
And the LH2 tank now reported at flight pressure. Both tanks, liquid and oxygen, now ready to flow propellants.
One minute.
Sound suppression water system is now being armed, which will flow water onto the mobile launcher platform at the rate of 900,000 gallons a minute, beginning at T-minus 16 seconds. The heaters on the booster joints are now being turned off. The orbiter computers have positioned the vent doors to the launch configuration. Standing by now for a go for auto sequence start. T-minus 33.
Countdown clock will hold at T-minus 31 seconds due to a failure.
We've had a hold. We do not know at this time what the problem is. We'll be standing by for word, but the clock is holding at T-minus 31 seconds due to a system failure.
And NTDSD, it's the LO2 outboard fill and drain valve. NTD is CMPL. Go ahead. It's LCC MTS 8. And PV9 outboard fill and drain closed power is off. It should be on. A recommendation? And NTD, we're in a no-go situation. We should have our open power, and we do not. Or excuse me, our closed power. SP. And MTS, can we verify that the valve is closed? Negative. We right now show a open position. We cannot verify the valve is closed. SP, this is MTS. Go MTS. We're looking at LCC reads. We have the closed power on and the open position off. We can cite
has happened is the ground launch sequencer would not hand off to the orbiter's computers to complete the count because the liquid oxygen fill and drain valve was showing off when it should be on. An analysis of the problem has begun.
We've been holding 2 minutes.
STE, this is CMTS. We're going to make an attempt to curse that valve closed. We've got the prereq set off. If this works, we should be in good shape.
I copy. Proceed.
Can work.
We have 7 minutes of runtime available on the auxiliary power units. We've been holding now about 2 minutes and 20 seconds.
STE, this is CMTS. The valve is closed. We'll go.
There's the confirmation that we have successfully
You're in the
recycled.
You're in the pickup terminal sequence MPS.
That's affirmative, so we'll go. We're in good shape.
Okay, you have a go to proceed. GLS, pick up the count immediately.
I copy. Mark. GLS is go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles. Booster officer reports all 3 engines stable at 104% performance.
Discovery, Houston, performance is nominal. And Discovery, 2-engine Ben Guerrier.
The 2-engine Ben Guerrier call means that Discovery could reach the transatlantic abort site at Ben Guerrier on 2 engines if it were necessary.
Copy, nominal performance, 2-engine Ben.
Velocity now 5,000 feet per second. Discovery 60 nautical miles away from the launch site. All systems continuing to perform well aboard Discovery. Velocity now is 6,200 feet per second. Downrange 100 nautical miles. The Environmental Systems Officer reports the FES is operating well. That is the flash evaporator system that provides cooling to Discovery's systems.
Discovery Houston, negative return, press to ATO, select Banjul.
Negative return, press to ATO.
That last call means that Discovery cannot return to the launch site at Kennedy. However, enough energy has been achieved to reach a safe orbit on 2 engines should one shut down, and Discovery could also reach the backup transatlantic abort site at Banjul if that were necessary. All 3 engines are stable at 104%. Auxiliary power units all performing well. Discovery's velocity is 8,400 feet per second at a downrange distance of 175 nautical miles.
Discovery, press to MECO.
Press to MECO.
The press to MECO call signifies that Discovery could make the main engine cutoff target.
Discovery, droop Banjul 109.
Droop 109.
And that last call means that Discovery could reach the Banjul transatlantic site on 1 engine at 109%. All 3 engines still looking good. Discovery's velocity 12,000 feet per second. Downrange 290 nautical miles at an altitude of 60 nautical miles. Guidance officer confirms that navigation is good.
Discovery, single engine Banjul 104.
Single engine Banjul 104.
Booster officer reports all 3 engines stable.
Houston, single engine press 104.
The single engine press call means that Discovery could make it to main engine cutoff targets on 1 engine at 104%. Discovery's velocity now 16,000 feet per second at an altitude of 58 nautical miles, downrange 435 nautical miles.
Discovery, late call, single engine press 104.
Roger. Fuel cell pH, we expect it.
Discovery Houston, concur, no action on fuel cell pH.
No action is required, no impact on that pH message. That message was expected during this phase of the launch. Velocity now 19,000 feet per second. 3 engines throttling back now to maintain the 3G limits on the vehicle. Discovery is 580 miles away from Kennedy at an altitude of 56 nautical miles. We are standing by for main engine cutoff at 8 minutes 32 seconds mission elapsed time.
MECO looks nominal from here.
And the booster officer also confirms a nominal main engine cutoff.
Discovery, we see ET-SEP. Nominal MECO, ohms 1 is not required.
The booster officer has also confirmed.
No ohms 1 required.
This is Mission Control. The booster officer confirms good separation from the external tank, and the flight dynamics officer confirms good performance on both phases of the ascent. No orbital maneuvering systems 1 burn is required.
Discovery Houston, for info, we've had some problems out of White Sands, but we anticipate a nominal handover to TDRS at 11 plus 30.
And Houston, we copy, and we had left L3A tail off during the plus 5 second dump.
Roger that, Discovery, we see it. No action for you now, we're still evaluating.
This is Mission Control. The ground control officer does not expect any loss of communications capability with the crew. We will be handing over to the tracking data relay satellite at about 11.5 minutes mission elapsed time. There have been some minor problems at the White Sands ground station, but they expect no particular impact from that. Booster officer reports that we see data indicating the main propulsion system dump is in progress. This procedure vents any remaining fuel or gases that may have resided in the engines at the end of their burn, just to make sure that those gases are vented out of the system and not present any problems for the remainder of the mission.
Discovery Houston.
Discovery, we're standing by. Go ahead.
Roger that, alarm. We're back with you through TDRS. Expect nominal ohms 2, anticipated delta V 4, 9, or 5.
Okay, we copy and standing by on your go for APU shutdown.
Roger that, Discovery, stand by. Discovery Houston, go for APU shutdown.
Roger.
This is Mission Control. The crew has received the go to shut down the auxiliary power units. And they've been informed also that the normal orbital maneuvering systems 2 burn will be done on time, which is scheduled for 42 minutes 39 seconds mission elapsed time. Change in velocity will be 495 feet per second, and that burn will put Discovery in an orbit of 330 by 310 nautical miles. This is Mission Control. Mechanical Systems Officer reports that the APU shutdown was normal, that the procedure looked good, and the configuration of the auxiliary power units looks good. This is Mission Control. The MAX officer reports indications that the external tank doors are closing aboard Discovery. Crew is right on time, following through the post-insertion timeline, or the post-ascent checklist, And at about 50 minutes mission elapsed time, just short of an hour, they will begin procedures in the post-insertion timeline. Max officer confirms that the external tank doors are closed and latched.
Discovery Houston, while you're on the way to Attitude, if you've got a spare moment, we'd appreciate a debris report.
Okay, Steve, stand by one. Houston, Discovery, for debris on the way uphill, right in the about from a minute and a half to 2, Charlie and I noticed several flecks of things impacted the forward windscreen. They seem to be pretty soft and just leave little streaks. SRB SEP put a pretty good little cloud on all the windows. And here at vacuum inerting terminate, we see lots of ice particles, but that's all normal. And between SRB SEP and MECA, we didn't really see that much debris that we can recall.
Okay, roger that, Discovery. Appreciate the report.
This is Mission Control. A guidance officer has reported that Discovery has almost completed the maneuver to the position for the Orbital Maneuvering Systems 2 burn. That burn is scheduled about 16 minutes from now at 42 minutes mission elapsed time. And that OMS burn will have a change in velocity of 495 feet per second and will raise the low point of Discovery's orbit to 310 nautical miles.
Discovery Houston, we see you in burn attitude and your targets look good.
Roger that, Houston. Hang on, Houston, Discovery, we see the tank and burn attitude down below us. It looks like it's straight down below us between us and Africa.
Roger that, Lauren, we copy, and about how far away do you think it is?
On the long axis, it would probably be about a 6 or 7 mil radius on the coax.
Roger that. Thank you very much.
This is Mission Control. The guidance officer has seen the data indicating that Discovery is in the proper position for the OMS 2 burn. And Commander Lauren Shriver was discussing with Capcom Steve Oswald that the crew could see the external tank below them on its way to the impact area.
And Houston, Discovery, are you still with us?
That's affirmative, Discovery. You're loud and clear.
Okay, as we've been coasting here, we've just been watching the external tank tumble, I don't know, 4 or 5 times since we called you last.
Roger that. Must be a beautiful view. Discovery Houston with some words on your burn.
Go ahead.
Roger, Lawrence, since we lost L3A, if you should lose an engine during the OMS 2 burn, an OMS engine, we want you to terminate the burn at an HP of 85.
Okay, we copy.
This is Mission Control. That last note given to the crew refers to the small reaction control jet number L3A, which failed off shortly after the ascent phase was completed. Propulsion officer thinks that that was due to a valve failure, perhaps in the oxygen valve system of that small RCS jet. Therefore, the crew's just been given a little note to change their procedure card. If during the upcoming Orbital Maneuvering Systems 2 burn, they should have an OMS engine failure, they would terminate the burn at an altitude, perigee altitude of 85 nautical miles in order to give flight controllers time to assess the situation and see what action should be taken at that point. We'll be coming up in about 2.5 minutes on the time of ignition for the OMS 2 burn. Once again, that's at 42 minutes, 36 seconds mission elapsed time. Delta velocity for the burn is 495 feet per second. Should raise the perigee of Discovery's orbit, or the low point of Discovery's orbit, to 310 nautical miles, resulting in a final orbit of 330 by 310 nautical miles. This is Mission Control. This is Mission Control. The propulsion officer reports that he sees data indicating that all the systems are in the proper configuration for the burn.
And Houston, Discovery, just information, the telescope remained powered up through ascent. We thought you'd like to know that.
Roger that, Discovery. That's good news. Thanks for the words. And Discovery Houston, your targets look good and your OMS configuration is good for the burn.
Roger that.
This is Mission Control. The propulsion officer reports seeing the OMS 2 burn begin and 2 good engines. Looking good so far.
Trevor, Houston. We're going to lose you here in about a minute on the East Hedris. Burn's looking good so far. We'll see you on the west side at 51 minutes MET.
So we copy 51 minutes.
This is Mission Control. We've gone out of voice and data contact with the crew through the Hedris East. In about 3.5 minutes, we'll pick up communications again on the Tracking Data Relay Satellite West. As we went LOS, the OMS 2 burn was in progress and looking good, and we should have confirmation of completion of that burn when we talk to the crew again. This is Mission Control.
Discovery Houston, back with you on the West Tidris. We see a good burn down here, 331 by 311. And your ohms configuration looks good.
Okay, we concur with that. We held off the gimbal check until we got back with you. We're ready to start that now.
Roger that, Lone. We're standing by. You have a go for the gimbal check.
This is Mission Control. The propulsion systems officer reported a good ohms 2 burn and good post-burn configuration. Flight dynamics officer shows that Discovery's orbit is now 331 by 311 nautical miles, and the flight dynamics officer described that as looking super. This is Mission Control. The crew is proceeding now into the post-insertion timeline, and we'll be coming up here in a few minutes on the reconfiguration of the data processing system. The general purpose computers will be taken over to the Ops 2 software. That's for on-orbit operations.
Review of the data is underway. No one in the firing room haste.
PLT, OTC, air ground 1.
Go ahead, OTC.
Okay, before you guys get out, we'll do some cockpit securing on panel 08.
Ready?
Left dome's tank ISO, B switch to GPC, and verify talkback open.
And Stan, we have tank ISO B. We'll verify it's in GPC and the talkback is open.
Copy that. Left dome's cross feed, B switch to GPC, and verify what position.
Summing up the problem, there were no indications anywhere in the countdown that there were any problems to work. However, at the T-minus 5 minute mark, when Commander Shriver was given a go to power up the auxiliary power units, he did notice some abnormal data displayed in the cockpit on APU number 1. Brought that to the attention of the APU systems engineer on the console in the firing room and to the launch director. The countdown clock was held at T-minus 4 minutes to have a chance to discuss it.
Copy that. Right ohms cross feed, B switch.
And as a result, a decision has been made to scrub for today while we look at the data and decide whether or not we have a minor problem or something that will take more time.
Talkback open.
And Stan, that's a complete GPC and talkback is open.
Copy that. Tank isolation 1, 2 switch to GPC and verify talkback open.
I'll verify those.
And 3, 4, 5 switch to GPC and verify talkback is open.
That's verified GPC, talkback open.
And CDR on panel 08.
Okay.
Forward RCS helium press A switch to GPC and verify A talkback open.
Okay, Stan, GPC and the talkback is open.
Copy that. Panel 07.
Okay, we're ready.
Aft left RCS helium press A switch to GPC and verify talkback open.
Okay, we verify it's GPC and open.
And B switch to GPC and verify talkback open.
That's complete to GPC and talkback is open.
Okay, aft right RCS helium press A switch to GPC and verify talkback open.
Okay, well, that's complete to GPC and talkback is open.
And B switch to GPC and verify talkback open.
That's complete GPC, verified talkback open.
Okay, panel 014.
Go ahead.
Row Fox, RJDA 1A, L2, R2 manifold driver switch off.
Okay, stand by. We're going to have to get the swivel sticks in. And if you'll start all over, just read it to us so we can verify the switch.
Copy that. Panel 014, Row Fox, RJDA 1A, L2/R2 manifold driver switch off.
That's complete.
And logic switch off.
That's complete.
Okay, RJDA 2A, L4/R4 manifold driver switch off, OFF.
This is Shuttle Launch Control.
That's complete.
Space Shuttle Launch Director Bob Seek
That's complete.
will meet with the engineers and the mission management team at a 10 o'clock tag up to discuss the data. In the meantime, he has instructed the launch team that until we have a better feel for what we're dealing with, to keep the options open and they be prepared to reconfigure for either a 24, a 48, or a 72-hour turnaround.
We're ready.
It will, however, be probably early this afternoon before we have a decision on what the length of that turnaround will be.
L1, L5, R1, manifold
manifold logic switch off, OFF.
Complete.
RJDF1A, F2 manifold driver switch off, OFF.
Complete.
And logic switch off, OFF.
Complete.
And panel 016.
We're ready.
Row Fox, RJDA, 2 Baker, L3, R3, manifold driver switch off, OFF.
That's complete.
L3, R3, R5, and manifold logic.
We are attempting to get some idea here in the Launch Control Center on exactly when a statement would be available on the exact nature of the APU problem and how long we will be standing down.
Logic switch off, OFF.
That's complete.
RJDF, 2 Baker, F4, manifold driver switch off, OFF.
That's complete.
F4, F5, manifold logic switch off, OFF.
That's complete.
RJD manifold, L5, F5, R5, driver switch off, verify.
Verify.
Right ohms engine valve switch off, OFF.
One of the things that comes into play in keeping our options open is the solid rocket booster retrieval ships, and until we have a decision on what we're going to do, they have been told to stay on station about 160 miles downrange.
And right switch off, OFF.
Right switch off.
And COOS, can you verify your CRTs?
COOS verified.
And PLT panel R1.
Ready.
Power distribution essential bus source, fuel cells 1, 2, and 3 switches off, OFF.
Okay, all 3.
The payload test team here at the console is preparing a plan for their activity over the next few hours, which ultimately will involve powering down the telescope. They are, of course, disappointed, but as Bob Seek said yesterday, the stars will be here tomorrow.
Yeah, CDR panel 013.
Yeah, we can see it to verify, Stan. I'm not sure we can open any circuit breakers if that's what you're going to need.
Okay. ISL, OTC. ISL, go ahead. Yeah, PCM and panel control. Or you still got it? You still have control of it. Okay, you want to set the active PCM remote enable on?
It is in remote. We are in remote this time. We have control of it.
Copy that.
OTC, CDR.
Go ahead.
Roger, that 013 stuff is critical. We'll have Steve unstrap and try to get those for you.
Okay, we want to open up the essential 1BC, 2CA, and 3AB controller circuit breakers to open. I'll give him a call when you let me know he's ready.
The flight crew is being asked to configure certain switches in the cockpit to accommodate a stand down, but in light of the uncertainty, to keep certain options open until decisions can be made.
Copy.
OTC, CGNC.
Go ahead.
Yeah, and sequence 18, steps 70 through 77 are complete.
The NASA test director has instructed the closeout crew to proceed to Pad B.
CDR, OTC.
CDR, go ahead.
While we're waiting for Steve to get up to panel 013, 15, how about on panel C3?
Go ahead.
I'll stand by. That's already in remote.
Engineers continuing to ask the astronauts, Commander Shriver and Steve Hawley, to assist in reconfiguring certain switches on board.
CDR, you get to panel 07.
Go ahead on 07.
Okay, TACAN 1 mode switch to off OFF.
Semi.
Copy.
Number 1 is off.
Copy that. TACAN 2 mode switch to off OFF.
That's complete.
And TACAN 3 mode switch to off OFF.
That's complete.
And panel 08.
Go ahead.
Radar altimeter 1 and 2 switches to off OFF.
Okay, radar altimeters are off.
Okay, and as soon as we can get Steve to get 013 and 015, our cockpit securing will be complete, and we'll get you guys out of there.
Okay. He's got that in work.
Okay.
OTC, this is MS2. Go ahead for panel 013, please.
Okay, row A, essential 1BC, main A, controller circuit breaker open.
That's open now.
Row Charlie, essential 2CA, main Baker, controller circuit breaker open.
Open now.
Row Easy, essential 3AB, main C, controller circuit breaker open.
Open now.
And panel 014.
Go ahead.
Row Baker, main A, main C, controller circuit breaker open.
Open now.
And panel 015.
Go ahead.
Row Baker, main A, controller circuit breaker open.
Open now.
Panel 016.
Go ahead for 016.
Row Baker, main Charlie, main Baker, controller circuit breaker open.
Open now.
Okay, I thank you guys, and that completes our cockpit securing, and the next step you hear should be the closeout crew opening up the hatch for you.
Okay, thanks a lot.
Sorry we couldn't give you a ride today.
Yeah, everything was ready.
OTC, CMQC. Go ahead. 1033, notice step 36 not performed, that affirm? Yes, next 5 steps starting with 33 are not performed, or next 6 steps actually. 33 through 38. Copy that.
NPD Launch Director 212.
CDR OTC.
CDR, go ahead.
Okay, we have one more slight requirement for you folks up there. We need an MS2 position to power down the HST.
Okay, stand by, Stan.
Sure thing. DLES OTC 212. DLES 212. Yeah, you want to perform this power down on this channel? Yes, sir. Okay. As soon as we get the MS2 in position, I'll give you a go to proceed. Copy. OTC, OVCC. Go ahead. Yes, sir. Close our cruise in the white room. Okay, copy that. We have the crew performing the HST power down, but you're free to get the hatch open and start removing those gentlemen ASAP. I copy and work. And OTC, PTC 212. Go ahead. Okay, yeah, Stan, you can give us a go. We'll get our folks over and... Okay. OTC, PD. Go ahead. I'd like to report completion of steps 19-0018 and 0093, and that is a recycle of the T-minus 20-minute configuration complete. Okay. And also OTC, I'd like to get a QC on 151. CMQC. Copy, 151.
OTC, CTLS on 212.
Go ahead.
Yes, sir. I will need a quality on 183, please.
CMQC, OTC. CMQC, copy, 183.
Thank you.
And OTC MS2 is at the standard switch panel now.
Okay, DLES, OTC. DLES, yeah. Go ahead. Okay, MS2, DLES.
Go ahead.
Okay, essential main switch, enable switch to on.
It's on now, talkback's gray.
Copy. Under essential bus, the external essential power switch to off.
Okay. The essential bus external power switch coming off, mark. And the talkback is barber pole.
Okay, and we should have an internal essential power talk back up.
That's verified.
Okay, take the internal essential power switch off, please.
Internal essential power is off on my mark. Mark, talkback's barber pole.
Okay, copy, and essential main switch, enable switch to off at this time.
Complete, talkback barber pole.
Okay, two quick verifications. The RSU heater power talkback is gray.
Verified.
And FHST shutters talkback gray.
Verified.
Okay, that completes power down. Thank you, sir.
Yes, sir.
Okay, CDR is OTC. I suspect that's all for the crew operations and the crew module. They're working on getting the hatch open and getting you folks down there.
This is shuttle launch control.
Okay, CDR.
You are seeing the senior management console in the firing room at the Launch Control Center. Launch Director Bob Seek, Mission Management Team Chairman Brewster Shaw, the Director of Payload Operations and Management John Conway. And a discussion has been underway about what our options are, and we still do not have any decisions, and it will probably be after lunch before we can tell where we stand. We have had a decision by Mr. Seek that we will not try to launch tomorrow. We will not try a 24-hour scrub turnaround. The Hubble Space Telescope is being powered down. We will be awaiting the results of the meetings this morning to determine exactly what the problems are and then where we would like to proceed from here. This will conclude our commentary from the Launch Control Center. We will continue with NASA Select to monitor the crew egress activities at Pad B. This is Shuttle Launch Control.
CTLS on 212.
Go ahead, TLS.
Yes, I just want to check in with you. Our recycle to T-minus 20-minute configuration is complete, but we haven't done anything with the clock yet. And I was wondering if you want us to go ahead and just scrub per sequence 30, and we'll just be on call for whenever they decide what the plans will be.
copy GLS.
Please repeat.
Yeah, that's affirmative. We'll go ahead and pick up with sequence 30 and then,
Okay, I copy, sir. We'll just keep checking in and make sure we get set up when as required.
right, okay.
And would you like me to go off on an off channel and buy off my sequence 30 steps?
Why don't you call them in on 132?
I copy, thank you.
RCRE, OTC. Okay, I've got a step here to remove ring safety flight code in OPSC and T-Lab for 5018. CDR, OTC.
CDR, go ahead.
Okay, you guys might get a master alarm when they pop the hatch due to Delta P.
Okay, thanks for the warning.
NTD, this is ECL 212. And CDR, OTC, air to ground 1.
CDR, go ahead.
And just one final verification, Lauren, that you are ready for flight crew egress and panels L5 and the R6 comm power switch is off.
Okay, I guess we'll get those off as we go off comm then.
Copy that.
We have people coming in now.
Copy that. OTC, CCL 212. This is OTC on 212, go ahead. ECL, OTC 212.
OTC ASP.
Go ahead, Ann.
Roger, OTC ASP is on board, ready to support the crew egress.
Okay, copy that. Can you verify that the panel L5 and R6 comm power switches are off OFF?
I'll do that.
Okay. And ASP OTC, air to ground 1.
Sir, OTC, go ahead.
Yes, sir. When you finish your comm reconfig on panel L5, I'd like you to go to panel A11.
Okay. A11, go ahead.
MS comm CCU power switch to off.
That's verified, and L5 and R6 are verified off.
Copy that. And panel A15.
That's on. I'm talking to you on that one.
Okay, PS comm CCU power switch OFF.
It was off when I connected, and I'm on back now.
Okay, MO39 Mary.
Stand by, I'm getting the crew out. We'll get that in a second.
Okay.
And MO39 CCU power is verified off.
Thank you. And ASP OTC.
Go ahead.
Don't mean to push you, but I lost track of where I sent you the last time.
Okay, we've got MO39. All the CCUs are off, and helping the crew unstrap and egress.
Okay, copy that. And if when you get a chance, you can disconnect the shoulder harness and lap straps, O2 hoses, parachutes, vent hose, and the comm cables.
That's all in work.
Copy that.